in this video, we'll do one example of subtracting numbers in scientific notation with different powers of 10. So remember, if the exponents are same, you follow these rules. If the exponents are different, you follow these rules right here, which is what we're going to do in this video. So we need to adjust the decimal to get the powers of 10 to be the same, because the exponents of 10 must be the same to add or subtract them. So to adjust the decimal, we follow Lars. Move the decimal left, you add. Move the decimal right, you subtract. Then, after you've adjusted the decimal and your powers of 10 are the same, then you can add or subtract the bases. In this case, we'll subtract, and then you keep the power of 10. So here's the example. 5.762 times 10 to the third minus 2.65 times 10 to the negative 1. So first off, notice these powers of 10 are different, so we're going to need to adjust. Now we need to adjust the smaller exponent to be the same as the bigger. That will save you a step in the end. So I have my exponents 3 and negative 1. It's important to recognize that negative 1 is the smaller exponent right here. So I need to get negative 1 to be the same as 3. To get negative 1 to be the same as 3, I need to go from negative 1 to 3, which means I need to move the decimal 4 places to the left so that I can add 4 to the exponent. Because negative 1 plus 4 will give me positive 3, and that's what I want my exponent to be. So let's adjust the decimal on that base number. So 2.65 is the base number right now. I need to go left 4. I need to go left 4 so that I can add 4 to the exponent. So let's add some placeholder zeros right here. That way I can see myself moving the decimal. I'm going to go 1, 2, 3, 4 places to the left, and there is my new decimal. Okay, so let's rewrite this problem so that we can see what we have now. This number right here has stayed exactly the same, so I'm just going to rewrite it. 5.762 times 10 to the third power. Subtract. It's no longer 2.65. I moved the decimal, so this is my number now. That's my base number, 0.000265. That's the base number, and then my exponent is times 10, not negative 1 anymore. Since I went left 4 with the decimal, I add 4 to negative 1. Negative 1 plus 4 is positive 3. That's the whole reason I moved the decimal 4 places to the left, so that my powers of 10 can now be the same. I have 10 to the power of 3, 10 to the power of 3. So I'm good to go. I can now subtract in scientific notation. Let's subtract the bases. Here's base 1, here's base 2. I need to subtract those. So 5.762 minus that base, 0.000265. If I subtract those two numbers, I would get 5.761735. So I subtract the bases, and I'm going to keep the power of 10, which is times 10 to the power of 3. So this is the specific answer right here. But let's round to the nearest tenth. Let's round this final base number to the nearest tenth. So I'm looking at the hundredths place so that I can see whether I need to keep the tenths place the same or round up. Since there is a 6 in the hundredths place, that tells me to round up. So 5.7 becomes 5.8 for my base number, and my power of 10 stays the same, 10 to the power of 3. So 5.8 times 10 to the power of 3 is my final answer.